Okay, it has started.
Yeah.
Thank you.
Thank you.
Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, salam sejahtera untuk kita semua. Our respected Mr. Dipjoti as Senior Product Success Manager Bentley System. Our respected Jamie Howe as Product Sales Engineer Bentley Systems. Yang terhormat Bapak Muhammad Taufikur Rahman MT, selaku water expert. Yang saya hormati dan saya muliakan Bapak dan Ibu peserta webinar baik dari PDAM, kontraktor maupun konsultan. Alhamdulillah, tentunya kita panjatkan puji dan syukur kehadirat Allah Subhanahu wa Ta'ala. Pada hari ini kita dapat menyelenggarakan webinar di hari yang cerah ini. Terima kasih yang sebesar-besarnya kami haturkan kepada Bapak dan Ibu yang telah berkenan hadir. Tentunya ini merupakan suatu kebanggaan, kehormatan bagi kami. Perkenalkan, nama saya Nesi dari PT Kurnia Handasa Nevada. Sekilas tentang Kurnia Handasa Nevada, kami adalah Bentley Partner Indonesia, authorized partner untuk penjualan software Bentley di Indonesia. Bentley Systems berpusat di Amerika, berfokus pada pengembangan engineering software, mulai dari perencanaan, desain, konstruksi, dan pengelolaan infrastruktur. Salah satu bidang yang menjadi perhatian utama Bentley adalah sektor sumber daya air. Tema besar 3 series webinar kita adalah Smart Water Loss Management and 24/7 Supply Resilience. Dari sesi pertama ini, strategi NRW, Non-Revenue Water, untuk deteksi kebocoran dan manajemen tekanan, bagaimana cara mengidentifikasi area dengan tingkat kehilangan air yang tinggi, serta penerapan manajemen tekanan otomatis untuk mengurangi beban pada pipa dan meminimalkan risiko kerusakan maupun kegagalan jaringan distribusi air. Hadirin yang terhormat, kita akan memasuki sesi materi pertama yang akan dibawakan oleh Jamie Howe yang akan memaparkan pengenalan produk yang berkaitan dengan water. Miss Jamie, the floor is yours.
Thank you so much, Bu. Let me share my screen. All right. So once again, good morning, everyone. Thank you for joining us today, and thank you, Bu Nesi, PT Kurnia Handasa Nevada, for joining us, for organizing this event. Before we start, could I please ask, make a request for all of you to kindly mute your mic so that there is no disturbance to other audience or participants of today's event. Yeah, so thank you so much once again. Without further ado, let's get started. So today I'll be giving an overview before the deep dive by Dipjoti later. As mentioned by Bu Nesi, this is a webinar series of 3 parts. Today we'll be covering part 1, which is NRW strategy, leakage detection, and pressure management. So in terms of a water network across many utilities today, one of the biggest challenges is actually water loss. A very significant portion of treated water, it was never built. It is simply lost in the network. So the problem is many of these leaks, they go undetected, which directly impacts the revenue of the water body. So traditionally, the water body will rely on manual surveys and inspections and a lot of trial and error to find out where the leakage is. So in reality, more time is being spent trying to find the problem rather than to fix the problem. So the key question now is, how do we address this? NRW reduction, it really starts with having visibility. So you need to know where the losses are happening, which area you need to prioritize, and how to avoid unnecessary solution like a blanket or a bulk pipe replacement, which is an impact to the cost. So this is where our solutions can help you move from the guessing work to data-driven decision making. Just an example here from Manilad in Manila. They have detected a major leak in a primary pipeline and they were losing about 30 million liters per day. So the challenge was that there were about 5 leak locations, and to physically inspect and find out all of them would be very costly and also time consuming. So by using open flows, they analyzed the flow and pressure data and simulated the network behavior. And this has allowed them to narrow it down to just one most possible location, which was then later confirmed at site. So as a result, they reduced the field investigation time by 80% and saved nearly 10 million pesos. And more importantly, they were able to fix the issue faster and also minimize any service disruption. So NRW reduction, it starts with knowing exactly where to act, and with the right modeling and field data, utility or water bodies can target issues faster and more effectively. And here, this slide here, it shows that to achieve that, you will need the ability to analyze and understand the network in detail. And this is where solutions like open flows come in. And Bentley's open flow solutions support modeling and analysis across water distribution, wastewater. Excuse me, sorry, I'm going to take a pause just to mute the person. Okay, yeah. So let me repeat, sorry about that. Bentley OpenFlow Solutions covers water distribution, wastewater, and stormwater systems as well. So these tools has allowed all engineers to simulate real network conditions, test different types of scenarios, and make more informed decisions. So ultimately, it will help to move from reactive operations to more proactive and optimized network management. And this slide shows that in open flows, we also offer different tiers depending on the scale that needs and the needs of your utility, from smaller systems to large complex networks. So the idea is to provide flexibility to all of you. So that you can adopt solutions that match your requirements. So today's focus will be on open flows water here. And we will take a look at the breakdown or the simplified comparison of open flows water. Is as mentioned just now, the differentiator is in terms of the size, number of pipes. In terms of number of pipes. So the difference is in terms of number of pipes, which is the size of your project. So from very small project, 100 pipes, 1,000 pipes, 5,000 pipes, and unlimited pipes to very large network. You can use the larger ones. And also the different tier covers different types of capabilities as well, from lowest to the highest. And lastly, we would like to also share a little bit on Virtuoso Practitioner License, which is available in which is Bentley e-commerce platform, where you can purchase license at an affordable price and bundled with free trainings. So how does it work? It is a flexible solution because it can be purchased by any entity, whether you're an individual or from a small or large organization, you can purchase the Virtuoso subscription. It is also flexible because it only lasts for 12 months. So if your project is for 2 to 3 years, you can use it for the period of 2 to 3 years. And after that, if you do not need to use it anymore, you do not need to continue the renewal of your subscription. And lastly, which is the trainings, the free trainings that comes bundled with the license that you purchase. We call it keys, where you can use this to redeem your free customizable training. So an example of how it works is when you purchase a Virtuoso subscription of open flows, it comes bundled with keys. And these keys will help to unlock different types of training that you can redeem. It can be on demand, which is recorded trainings where you can watch it at your own time and pace for a period of 90 days, or it can be customizable or specific to your project or team requirements. This can be done in tailor-made training programs or mentoring services for your specific project as well. All these are done online through Teams. And the number of keys also varies depending on the product tier that you purchase. So for water, open flows water, the lowest two product tiers, the essentials and standard, it comes with 1 key per license, and the advanced and ultimate with 2 keys per license. And for this work suite here is a combination of water and sewer only if you have the requirement of both water and sewer in your projects. Otherwise, just the water, the solution will be sufficient for you. And 1 key is almost 2 hours of free training that you can redeem. And so in summary, Virtuoso subscription is a practitioner license and name user with yearly investment and without any additional maintenance fee. So with this, you will have full control over your yearly software costs, and throughout your active subscription period, you are eligible for free technical support assistance, free software updates if there's any releases, new releases, and also the expert services that you can redeem using keys that come bundled with your license. And if you need any further information, do contact Bu Nesi or PT Kurnia Handasa Nevada. They are one of our channel partners here in Indonesia, and we are happy to work together with them to assist you further on any inquiries that you have. So with that, we hope that this quick overview of how NRW challenges can be addressed through better visibility and also data-driven approaches can help you. And I'll now hand over the session back to Bu Nesi before for her to introduce our next presenter. Thank you so much. Thank you, Bu.
Thank you, Jamie, for
Thank
your
you.
explanation about Bentley. Thank you so much. Now, we will move on to our main session delivered by our keynote speaker, Mr. Deep Jyoti, as a Senior Product Success Manager, Bentley Systems. Hi, Mr. Deep.
Hello. Hello, everyone.
Hi, Mr. Deep.
Hi.
Yeah, because English is not our first language, could you
Yeah,
speak slowly when you
sure,
explain about your representation, okay? Okay.
sure, sure.
Yeah. Thank you, Dipjoti. The floor is yours.
Thanks, everyone. Good morning, good afternoon. So just I'm sharing my screen. My screen is visible, right?
Yes,
Yes,
Deep.
visible.
Uh, okay. So hi, everyone. Jamie has already introduced about this, gave a brief about our applications. So we know that water is essential for life, and yet we often face challenges for that. So there is not enough uh, where we need it, and sometimes too much when it's not safe. So infrastructure is how we overcome all these challenges. Though today's focus is on NRWs, okay, non-revenue water. I will talk about non-revenue water different strategies that you can create with open source solutions and overall the power of the applications it has. Okay. So not only with the DMAs or the strategies, but the overall idea of the software that can empower you with like not tool, it's like an design optimizations applications where you can plan, design, build, and also do the operations and maintenance parts too. Okay. So Bentley continues to be at the forefront for infrastructure in engineering software. So water is one of our priorities, and there are a lot of users, thousands of users globally we have for open source solutions. So now let's have a look on uh, the water utilities, water where we can do a lot of things, right? So Bentley helps you to design, build, and operate water infrastructure more efficiently, and this is not the limit. Okay, you can go with the NRW's strategies. You can do the pressure controls. You can go with the water safeties. Why I'm saying this? You can do the water quality analysis too. You can go with the pipe renewal planners. One of the important feature is that you can do multiple iterations in a single model file. So what happened? You have one models and you want to do a lot of changes on there. You want to run that with different demands. You want to run it with like you have a new expansion. Okay. So the thing is that in this software, you can do all this thing in a single model file. No need to create a new model for that. You can compare your model and you can just take the best decisions for it. Okay. Uh, so the thing is how you are actually working with all of these tools. Okay. So what happened couple of times, we don't need all the tools, but we should know about that, how it actually works. So, so from the master planning to everything, it helps you for complete network optimizations. So now let's see about the few of the points that the software has. One is the interoperability. So what is the interoperability? So I know that someone of you who have joined are maybe expert in CAD, okay? Because in civil engineering we also have learned CAD when we are in BTECs, and maybe in our GIS, okay? So we have a complete interoperability with ArcGIS Pro, AutoCAD, Civil 3D. So on their platform, you can also use our applications. So that is the interoperability. So any one of you who are experts in, who also in water and also CAD or GIS, they can work on these solutions. So no need to just open this as a standalone, but you can also do and can avail all the features of these applications in uh, like MicroStations, ArcGIS Pro, AutoCAD, all this. Okay. Now you may have the questions that if you have some GIS or CAD files, could it be open in this application? And my answer is yes. You can create, you can integrate all this CAD and GIS informations here very quickly. So what happened when you are doing any modeling? We usually don't go with the layouts or the one by one, the manual. You can do according to the Bing maps in the background, any of the CAD maps, any of the shape files in the backgrounds, any of image even. But if you have a large network, you can just integrate the road center line and can create the model very quickly. So you can simulate, predict, and solve the network system problems. You can optimize. You can do 24/7 analysis. Even you can optimize the pump performances. You can make pump schedules. You can go with this, the what is the energy cost. Okay. You can compare different energy cost tables. Okay. So there are a lot of features it has. You can go with the Darwin calibrator, Darwin designer, but Darwin calibrator will help you to calibrate the models. I will talk about this in our demonstrations. So today's point is NRWs, and it's a huge challenges, and it caused by the leakages and also the pressure issues and inaccurate system monitoring, and pressure management and DMA plannings are the key of the strategies. So how efficiently you are creating the DMAs using the valves, using the pumps, using the isolations valves, everything, that's very much important. You go with the customer meters and can track all that thing with the according to the different pressure zones. So I will demonstrate how utilities can use open flows of water with all these features like optimizations of DMAs, implementing pressure management strategies, and you reduce the leakages. Now, let's have a look on that for a simple modeling, that what data you require and what you get as an output. Okay. So you build the network, provide the reservoirs or the tanks, provide the junctions, entered all the elevations of the junctions and the demands to provide the demands, and give the pipe lengths, C factors, and the diameters. Okay. Additionally, if you have pump pulse input, give those inputs. Now, just compute after computations, you will get the output as the pressure, velocity, hydraulic grid line, head losses, And this is not limited with this results. There are a lot of results in graphs, in animations, in profiles also. And you can compare those, you can make this in a tabular format, and there are a lot of multiple ways to showcase those results. But for a simple networks, I'm just giving you the understanding that how it actually works and what data you require. Now, let's see about the process. So first, when we do the model building, we create the model geometry, we extract the elevations, we assign the demands. We have the lot of applications available in market, which are free applications, but they don't have those ability to make all this CAD shape files integrate in your models very quickly. So, and those applications are not advanced. You could not make that interoperable with CAD, GIS. You could not do the optimizations automatically. You could not like just provide the diameter sets and software will choose from the diameter. Those things could not happen. Okay. You could not make multiple scenarios with multiple alternatives with those freeware applications. Okay. And it has, I'll show you that it has a different demand assignment programs. So as an example, when you do this model geometry, so the model could be done from any of the data sources. So it could be like CAD, SQL, Oracle, S3 shape files, QGIS files. Even from Excel, you can just import the data. The model will be automatically built. You need to just map the elements, like what are the which junction, which is the junctions as the point, which is a polyline as a pipeline. You just need to mention. Even if you have much more uh, mm, attributed data, if you have like pipe diameters, if you have like the elevations, everything you can just import through model builder. So there is another way that is called TREX, terrain extractor tool, by which you can just make that contour maps available in the background, and all the junctions, elevations will be imported from the data you have provided. So it may be like shape files, it may be like anything. So you can easily just integrate the data and can make it like complete model files by few seconds. So next is that different methods of the demand applications. You can do the manual methods. So you can just going to the junctions and providing the loadings. But again, that is a huge time-taking task. But with the flex tables, you can do it rapidly. But this is like automated methods. Like you can do like proportional distributions by area, equal flow distribution, proportional distributions by population. You just provide the densities and shape files, and the software will distribute the loading as per the requirements. Okay, as per the different methods you are taking. There is another method called unit line method. So it will distribute the loads. For as an example, you want to distribute, you have the loadings for one village and you want to distribute it. So it will distribute according to the lengths of the network. Okay. So when you have less information, so you can follow these methods. You can calculate the Thissen polygons and can distribute according to the Thissen polygon areas. You can go with the customer meters or the building meter methods. You can go with the flow area polygons, populations, or the census polygons. You can use also land use polygons too. Okay, so when it comes to on the reports, there are multiple ways for that reports. You can go with the shape files, you can go with the CAD files, land XML files. You can uh, also export as an EPANET files. Someone of you may be the user of EPANET also. So all the files you have in EPANET can be imported here, and you can make much more on it, those which are not available in EPANETs. Okay, so you can import all the model files in EPANET and can make advanced arrangements on it. You can make that pump and all that's like different control sets, extended period simulations with like if you want to make with the pump schedules, you do the optimizations, can do everything can be done here very quickly. And you can showcase all this with good graphics and all that like pressures, the velocities, everything can be done with the custom reports. Okay. Let me show you one of that integrations with this ArcGIS Pro. So this is in the ArcGIS Pro interface, but using as an open flows of water. So here you can get to see that these are from GIS, and but this like reports, tools, labeling data, these are from like components are uh, from OpenFlows Water. So I am using OpenFlows Water, but in GIS applications. Okay, so in the left, you can get to see those contents. Okay, so here in the background maps, so this is flow graphs. So you can create quick graphs from the pipe table. So you can get to see the pipe tables, all things in a tabular format of this is like the tables available in standalone, but you can make this available in GIS or the CADs too. Okay, and you can get to see the flows in attributed table. If I open, so you will get to see the attributes for as GIS and also the flows which came from this computations of these models. So any of that, so just if you just initialize the symbologies also and color code also, and you want to make the annotations, you can do that. So I'm just doing a flow range and will color code the network according to the flow. So you'll get to see that the colors are changing of the networks. Okay, so these are the different colors of the flows. Okay, and you can just do this thing with for junctions. So this is like GIS integration. Similarly, you can do with the CAD integrations, and you can do all the features, all that possible ways of the using open flows water tools used on that platforms too. Okay. So now let me show you here with this one of the time browser. So when you do extended period simulations, you will get to see that the color of that networks will change. Okay, because obviously we are doing running that EPS one. Okay, that same that which we can do in the standalone, you can do it in GIS or the CAD platform too. So let me show you that water supply network workflow. So first we do the topographical survey, we do population forecast, demand estimations, then we do the zoning, and then modelings and analysis and designs, and the finally report preparations. So from zoning to the report preparations, all the steps could be done with OpenFlows applications. So now let me show you one of the key strategies for the 24/7 analysis. So then it will be much more clear, that how it actually we do the 24/7 analysis. So we divide the project based on that WTPs and do the surveys for zoning and pressure zones. We make the pressure zones. You must create the DMS and the so pressure zones will not be the same as the DMS. Okay. So I'll come to these things later. So we do the population forecast, estimate the demands, and design the head works and WTPs, the transmissions mains. So now you can also avail the transient analysis in OpenFlows water applications too. Previously, you have to purchase OpenFlows Hammer software and as a separate entity. But from last year, we make this available with OpenFlows water too. So if you want to make the transient analysis for your rising men, you can do in OpenFlow solutions too. Okay. So we do the conditional assessment of extra this infrastructures, and we plan the new pipelines. So you can go with the rehabilitation studies. What is the new, what is the analysis with that existing structures? Excuse me. So, so the methods here is that we first mark the unserved areas and we propose new service reservoir for this to maintain some pressure that is recommended in your guidelines. And we do the hydraulic design for all operation zones and DMS to discard the old pipes. So you can go with VFDs pumps where you can just set that variable curves according to the curves so that the pump will work. And you can design the exclusive feeder mains for each DMS for the outlets for the ESRs. So each DMS will be isolated by the isolations valves or the bulk meter or FCVs or other any valves. Okay, so all that valves you can create here, and you can go with the DMA wise measurements to the NRWs. You can monitor the water entering the DMAs and measure the consumptions by 100% metering. Okay, you can make that metering systems there. And slowly all DMS will be converted to 24/7 pressurized systems. And you can regulate the pressures in the DMAs using VFDs. And additionally, you can go with the SCADA or digital twins. You can integrate the SCADAs with the real-time analysis and get to see all that as a real-time, the pressure drops, the changes of that different like velocities, everything in HMIs. And even you can much more advanced way, you can do the integrations with water sites where you can make all these things in a cloud-based platforms. So so like this with the smart meterings, and with that you can make that NRW strategies. These are the complete of that workflow for you, what we follow in open flow water for from starting of the models to the DMS metering to the leakage detections. We do the calibrations with the Darwin calibrator. You can do the criticality study, pipe renewal planner, and also the SCADA simulations. Uh, Now, here is one of that example of that network. So here in that reservoir, it's coming to a network you can see. So in the background, that this is a beam map. So this is the this is a rising main, and with the 4 tanks, and that this is the distributions network. So I have run with 2 scenarios. So this is the different scenarios, something like that you can create. I have run with the pump patterns, and just changing the time browser, you will get to see that how the pressure is changing, because I have changed that with the color codes. Similarly, you can just set these patterns for the EPS, extended periods run, and can assign this to the loading, so that the load will change, and obviously the demand changes, and also the pressure will also change with this. Okay, with that pipe diameter. So this is like how you can get to see in that tabular formats. The pressure is changing with the time. You will get to see the hydraulic rate, everything's. So additionally, you can go with the tanks and the graphs. You can compare the pump graphs, tank graphs. You can set the controls. Even when you set the controls, you can make the pumps make on and off according to the time, according to the level of the tanks. So this is with the times how that tank level is changing. So similarly, you can do the pump setups. So here is we have the pump and pump controls. Uh, Much more advanced way, you can go with the fire flow analysis, energy cost analysis, Darwin designer for optimizing in automated way. Okay, so uh, as for that NRWs, we know that there are 4 steps in the digital workflows to manage water losses. Okay, and to improve the network reliability using open flow waters. That's how we first identify the water loss location using Darwin calibrator. You then prioritize pipe repairs using criticality analysis. You then optimize the network pressures to minimize leakage. Then you prevent with jet analysis. So overall, the workflow helps the utilities to uh, detect the leaks, prioritize the repairs, reduce NRWs, and improve the system reliability. So the thing is that what are the how that NRW is the critical. So many cities have NRW levels of 30 to 50%. So in that reduction strategies, there are multiple ways though, not only the DMA. So DMA will divide your network into smaller zones and ensure that limited inflow points, flow meterings at the entry, and helps you in zone-wise NRW calculations. So, but there are also ways for you can do with that calibrated hydraulic model. So you just import the networks, load the demand data, go with the SCADA or the field data. I will show you, and The calibration ensures model reflects actual ground conditions. So you can compare the leakage. Okay. You can go with pressure dependent demands, that PDD, that is one of the game changer. So uh, you know that where is the higher pressure, where is there will be the higher leakage. So realistic behavior. So according to that, you can do that. So but the pressure management with the most effective ways, you can just go with the PRVs, PSVs, and FCVs, and can identify that high pressure zones. Okay. And you can reduce the pressures to optimal levels. So you can go with the nitro analysis, simulate low demand period, like as an example, 2 to 4:30 a.m. Okay, and can if you just get to see that flows, so you can just pinpoint the hidden leakages. Okay, so another methods are like the scenario comparison. So now that the DMS actually uh, what is a DMS actually? DMS is the hydraulically isolated zones. Actually, it helps to make the inflows measured, consumption is monitored, leakage and NRW can be quantified. And in open source water, you can do this with isolation valve, closed valves, metering nodes. So the DMA creation strategy is that you import the network, go with identify the logical zones. How you will create the zones? You just create the zones with the topography, pressure zones, and you create the isolations. So you can make this isolations also helps there. Okay. And you can ensure the single or limited inflow points. You can assign flow meters, place the DMA entry points, use flows, meters like FCB, GPBs, and tag the DMS. So you can make this DMS analysis. Okay. So in the DM analysis, like we will get to see this, what is the inflow and what is the consumptions. And between that, this difference, we just calculate the losses. So so let me show you that the different ways that in open source water it could be. Okay. So this is here that with the Bentley's open source water, you can do. Okay, so you may have the questions that, can I do all these strategies? My answer is yes. So you can go with the understandings of the water losses with that water balance. So you can directly get to see that the different pressure zones and what is that the hydraulic rates and the pressures. You can do that DMAs and PRVs. You can go with the leakage detection strategies using the field measurements, and uh, you can make that the pipe renewal planner to calculate the pipe burst. Okay, so so when we do the criticality analysis, we identify the which pipes are most vital or which areas should be shut down for efficient leak repairs. So similarly, you can go with the pipe renewal planners. So when you do the pressure management, the key concept of this is the pressure management aims to that maintain the optimal pressure levels in the distribution systems, and excessive pressure increase leakage rates and pipe burst. And on that ways we can make it. So the process is that analyze pressure distributions across the network, identify high pressures zones or the critical nodes, and simulate the PRVs. Okay. Uh, Uh, so all that integrated approach are available in open source applications, from DMS to pressure zones managers. So here is one of that these DMS tools, and you can get to see that the DMA wise, the number of pipes, the boundary conditions, you can color code them according to the pressures. Okay, so you can also make that there are different zones. So the pressure zones actually divides the network into areas with similar hydraulic pressures, and these zones are typically bounded by closed or control valves, where DMAs are smaller. Okay, so you can create both in a same file. So this is the beauty of that application. So you can just go run with that uh, like pressure zone managers to help to identify which elements belong to each pressure zones and simplify model management. But in the DMS, you can improve the NRW calculations. So with this creating DMS, you can prepare and validate the hydraulic model and define DMA boundaries using those hulks. Okay, and add the flow meter at inlet. So it will directly showcase you the DMA wise flows and everything. Okay. So the tool actually uses the clustering algorithms that groups highly connected nodes together while minimizing connections to the rest of that network. So by automating DMA creations, engineers can quickly evaluate network segmentation, analyze flow balance, and identify the optimal locations for meters and isolations. For okay, you can also merge the adjacent DMAs and highlight the zones and refine the boundaries. Okay, so it's not like you have to just fix the boundaries. So this tool I have already talked about the Darwin calibrators and the leak detection. So uh, this is where you reduces the time required for manual calibrations and ensures the hydraulic model accurately represent real world system behavior. So I will show you that the step-by-step guidance that how that you can just compare with the field data and the model results and go with the leakage detection. So when observed flow is consistently higher than the model demand, the system may indicate possible leakage locations. And you can go with the optimized automated ways with the Darwin calibrators algorithms for like you can just adjust the parameters like pipe roughness, demand, and you can change. You can see this observe difference between observed flow and that the leakage. So here is one of that. Just let me show. So I have just got to know this the 6 points of the 6 junctions for that observed pressures. Okay, so I will run Darwin calibrators with the field data. So for field data's input, you can just this is like the model data. Okay, I have run with the now I want to go with the observed data and want to make the input. Okay, so this is like from that field data. So I have just given input. Okay, so these dots are representing which I got from the real data. So if I compare that, I need to create another scenarios, another that curves. So with that, I have created this uh, this field datas. Okay, so this is a different for 15 minutes each of that field data. So I, as an example, I want to create the leakage detections at 3 a.m. Okay, 3.25 a.m. Okay, so that is like 3:15 a.m. So here I am just creating that that demand groups. Okay, and making just availables here just to show you one thing. How this will detect. Okay, so I will detect according to the maximum trials, and this is the minimum emitter coefficient and maximum minimum emitter coefficient. You can also change, you can make it as like 0.8 or 1. Okay, and additionally, this is the maximum trials, and you can get to see that the number of leakage nodes I have detected as a 6. And if I just sort it, so it will show you the adjustment emitter coefficients. So this is in that 6 junctions. I have changed the emitter coefficients, and I will create new new flows on that and can compare the leakage. So this is like if I just compute that, it will make the different solutions with the different original and emitter coefficient and calculated. And then you can create the observed pressure versus the actual flow of observed flow versus actual flows. Okay, and can compare those. So just I'm showing you that this is the from the field, and I have created it from observed data's new flows. And if I just make this available, so okay, so this is quite similar with this. Okay, you get to see this with the dots, and you can compare those. Okay, and can just with this comparison, you get to see the values of hydraulic grades. Similarly, you can create for that leakage detections for more times, and you will get to see that which is active, so like where you are getting leakage. So at the time of like 3.25 plus 10 hours, you'll get to see there the 4 junctions where there may be the leakages. So So the Darwin calibrators is another tools which reduces the time to required for the manual calibrations. Okay, and can help you to compares. So now you can also create more calibrations and can do by very quickly. Let me show you this with the SCADA system integrations. You can just, this is where OpenFORCE waters comes in, that the powers. Okay, the gaps of informations between sensor reporting to the SCADA data. So realistically, you don't have a pressure sensor installed at every corner or every street, but you do have a hydraulic model, and you can use that to determine where the high or low pressure actually exists in the system or the projects maybe for the futures. You can do with the historical data also, or with the live sensor data. So if we supply the hydraulic models with live data, you can see when and where there may be a problem before it occurs. Okay. So with the advancement of that, so you can go with that like pipe burst. Not only the pipe burst, you can do with the fire event simulations. You can just export the results to SCADAs, and there are different events like pipe shutdown, power outage. So multiple events you can create and can go. As an example here, I have just making that isolations valve, and I want to check that which area will be affected. Okay, so I can just make it and can see that with the times that how that which customer will be identified and the risk. Okay, so uh, so similarly, you can also go with that the results in like you can export that results in your machine interface that I have mentioned previously, and you can get to see all that in with this HMIs. Okay, that how the changes of the pressures and everything. So, okay. So this is what you can SCADA Connect simulators. With new update, we have the digital twin integrations. Okay, so and now we use the extend the capabilities of OpenFlow Water, directly integrating it in water site, where you will get to see that what will be the NRWs and everything, not only the NRWs, but all the management and alerts, everything, the pressures in a cloud-based dashboards. Okay, so OpenFlow's water could be integrated with this OpenFlow's water site, where you can get all the anomalies and zone-wise flows and everything. Okay, so uh, here is a quick look on that how it actually this customizing and flexible reports you can create. You can create zone-wise NRWs and also the average daily NRWs. You can also predict and overall for the months, overall for the years. Okay, so let me show you a few case studies too. Okay, uh, so this is one of the case studies with Manila waters. Okay, so uh, this Manila Water Company leveraged open source water to address the critical issues and their central distributions network benefiting 3 million households. They have used with this Manila waters to optimize pipeline replacement, install pressure reducing hulls, and reconfigure the networks. And OpenFlow's water seamless integration with GIS data saved the time, cost, and also the software helped them to reduce the inner roots. Okay, so that is more than 50%. Uh, there is another cases like Singapore's national water agencies. They have created second case studies that here I would like to showcase you. So uh, if you don't know about a lot about this Singapore, the country has a small footprint but has big environment challenges. So Singapore PUB previously built a smart grid using IoT sensors, but operations was still finding it difficult to find and localize the pipe leaks and underground burst that contribute to NRWs and wasted environmental resources. So uh, so Bentley developed an AI-powered second. Uh, evergreen digital twin, which uses the advanced data-driven numerical models and physics-based simulations models. Okay. So in the digital twins, they uses AI and machine learning to actually locate them automatically on the maps, significantly reducing the manpower with more targeted field view efforts. So this was done with this like open flows waters and that water cycle equations. Okay. So so this case studies is one of that like R&D projects, okay, and they have used open source applications uh, with their challenges in a lot of creative ways. Let me show you one of the case studies from Indonesia. So this is for the DMS creation. So it has the residentials and commercial areas also. And the leakage percentage was more than 40%. Okay. And the total consumptions also, if you get to see that, that's like more than the leakages. Okay. So they have just run with that's the night flows with the PRV conditions and with that night flows, they have just checked that which area is getting the leakage. So with the field logger and the customer meters with open flows water, they have just logged the flows. Okay. And for different times like 2 a.m., 3 a.m., and they run that with their calibrators and just run with that where it will be the flows. So so this is a different DMS and where they have placed the flow meterings and that logger locations. So in the different locations, they have just created that logs. And all that logger informations they have just put there. And from that, they can just roll the flow meterings things. They have analyzed and the report with their investigations and in the all of that areas with that housing estate and the different zones and the pressure zones and compared those with the different scenarios and with the field investigations reports. And from that, they have chosen what is the leakage will be. Okay. So I can show a lot of case studies, but you can also check it in our websites. Okay. So if you have any questions, please feel free to ask me.
Thank you very much, Deepjyoti, for your detailed and insightful presentation. We truly appreciate the knowledge you have shared with us today. Hadirin yang terhormat, sekarang kita akan memasuki sesi tanya jawab. Pada sesi ini akan dipandu oleh Bapak Muhammad Taufik. Kepada Pak Taufik, dipersilahkan.
Baik, terima kasih kesempatannya Ibu. Baik untuk Bapak Ibu, apabila ada pertanyaan boleh bertanya langsung maupun bisa menuliskan di kolom chat. Boleh bahasa Indonesia atau boleh bahasa Inggris. Silakan, kita feel free.
I can see a few questions, but that's in Bahasa Indonesia, I think. Oh, no. Okay.
Baik, Bapak Ibu. Mohon bisa menuliskan pertanyaan apabila ada yang ingin diketahui lebih lanjut. Or I will start the question for strengthening the knowledge about this open flow water. Like Jyoti, you have share about this open flow water in 2D model. So can the open flow water do the 3D models, and what times we can use that 3D model?
You are asking for the 3D models, right?
Yes.
That software could do 3D model or not.
Yeah.
See, open in water network analysis, we don't require 3D model because I am saying what. So here in that analysis, the pressures, velocities, the optimizations of with the diameters. That is much more important than to visualize it in 3D. Okay. So it's not like structures, what we do that, or or geotechnical engineering where we need some 3D views and all that. You can create all that profiles, all that maps, and from that engineers do the design and the executions. So 3D not possible with these applications because it's not required actually. That's why we didn't created something on the 3D applications. But what you can do, you can integrate these networks with open roads where you can visualize clash detections in 3Ds. Okay, so there may be utilities like uh, sewer, storm networks. Okay, so where you need to check that where water networks is. So that can be done. Okay.
Thank you for your brief explanation.
Thanks.
Baik Bapak Ibu, silakan apabila ada pertanyaan. Boleh ditulis di kolom chat dalam bahasa Indonesia, nanti kami bantu untuk menanyakan ke di chat Bu Jamie. So this is one question from Pak Ben ya. Hi Mr. Jyoti, thank you for that. So
Okay. I got your
question
questions.
is,
Yeah.
yes. Okay.
First question is that should the water utility agency in Indonesia does not have any detailed raw data for this, what we have to do then? So when you don't have the real raw data, but you must have some data, right? You have must like, you know, the areas you have in the Bing maps, it's quite same like as in Google Maps. You can place it in the background and can create the network. Okay. So as an example, you don't have CAD maps, you don't have the shape files. You can just put the elevations from any GIS, QGIS, ArcGIS, and create the networks. You may have the road center line. Okay. From the road center line, you can create the network. Okay. So you can just put, there are a lot of ways to create the network if you have nothing, because you must have the maps like Google Maps and the Bing Maps in the background. Okay. And from that, you can create. Now, if you have anything like any contour maps, anything that will be obviously helpful for it, because it will much more fasten your modeling process than to do all these things in manual. Okay. So I think you got my points. Second is that in the Darwin calibrator, we have to choose the lowest fitness values as the best solutions. Why? We have created the fitness value as the indicator of the what is the total cost and what is the in the calibrations, that what is the best solutions with the most optimized run. So most optimized is the best fitness. Similarly, in the Darwin tool, what happened? We create this as for uh, we are changing the emitter coefficients. So when we are changing the emitter coefficients, that also the pipes also changes. Okay, that the demand changes. So there are pipe roughness changes that can be done. Okay, so on the most optimized, we created the most fitness. So that is the only thing. Nothing much more with that that you have to bother about that. What is the fitness values? It's just indications of that. Okay. Most fittest. So you can create for the 10 solutions you can run. Okay. The software will give you probable 10 solutions, or you can go with the 3 solutions. So in the optimized run, similar ways, you can do that. I got 2 questions, but in
Okay.
it is in Bahasa Indonesia. So please, if you just.
Okay, I'll answer for you. So first question from Andri from Perumda Tirta Pakuan. So how to reduce the water loss from 24% to 23%? Only 1% that target, and what should be done with the supporting tools? Okay.
Some issues are there. Could you please tell me the questions once again?
Okay. Once again.
Someone has
So,
just
yeah.
exited me
Okay.
from the meeting. Yeah.
Yeah. So how to reduce the water loss from 24% to 20%, 23%? Only 1% that targeted. And what should be done with the supporting tools?
So NRW reduction 24%, 23%.
Yeah. They only targeted 1% upgraded from 24% to 23%.
Okay. So in that case, that I have showcased that the ways that you can go with the DMS strategies. You can just go with the different isolations valves and get to see that where is the leakages and all that. Okay, and from that you can go with the pressure management things. So that is one of that points. So pressure management will be the best solutions with the DMS and the, like flow metering. So you place that flow meters. Okay, so flow metering could be done with this open source solutions and can just check that which area is getting much flows, and then you can control and can go with that. Okay.
Oke, apakah ada feedback Pak Andri? So I'll next to the next question ya. So next question is from Pak Muhammad Gifari. Is the secondary elevation data from DEM or Google satellite accurate enough to be used as input to the system?
Yes, if you have that, that can be means it's like DM and all that Google satellite image, right? It's saying, yeah, that can be done. None. All that. If you have digital elevations model, then you can create a also the contours and everything very quickly. You just import that DM and it will automatically do the elevations from that, and you can create this. Okay.
So the next question from Perumda Ayam Tirta Girinata, Kota Cirebon. So they ask about how the percentage the accuracy to wait. So they ask about the accuracy level in terms of water loss.
What they are asking?
For the open close water. How the percentage accuracy to
Okay, so
get to
they are
NRW.
asking that what is the accuracy of these models and all that. Okay, so see, obviously that like 1% errors maybe like that, but the thing is that how you are providing the values and how much efficiently you are doing that all models. It depends on that. So globally our applications used, okay, so in most of the water distributions to irrigations in projects, okay, so again that we have the human errors when we do the executions thing, okay, but this model could be used for that, taking as a minimum errors that we take for as a thumbnail, okay, so that's fine. Any other questions, please?
Yes. Apakah ada pertanyaan lain, Bapak Ibu?
Pak Taufik, kalau untuk
Ya.
yang Pak Andri, apakah sudah clear? Beliau menuliskan di kolom chat kehilangan air dalam per zona DMZ sampai ke DMA.
Oh, yeah. Yeah. So, this is for the NRW water loss from 24% to 23%. The next question is, the next problem is the lost water from our per zona DMZ zone to the DMS. So can we do something to reduce until 1% to I think this is based on
We just
the
have
project, yeah.
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 Some links are also given by Akshay, so you can also have a look on those links for much more detailed answers. Okay, so you can just go there and can have the ideas of that step-by-step guidance and how it could be. Okay.
Yeah.
Connected to the existing ones.
There is a question from Park Ben. I did. There's a question in the chat from Park Ben.
Okay, so in the chat, right? So
yes.
Okay, so do you have the suggestions that what the first thing you have to do? So once you build the new one, okay, so you need to study that the rehabilitation studies of the networks, the existing networks. Okay, so you divide the existing network. So if you cannot reduce the NRW if you cannot measure where it's happening. So you need to divide the existing plus proposed networks into DMS and define the boundaries and what is the inlet points. You can go with the flow meters at entries and you can do the water audits. Okay, so first of the things. So go with the inflows, the consumption, the NRW's percentage for DMS and high lower losses zone, and you make the pressure zones then and model the systems in open flows of water and floating with the existing one plus the proposed network. Okay. So you can do the 24 hours analysis or pressure dependent demands, PDDs, to predict the NRW's behaviors and also do the optimize the networks. Okay. So that DMA creation is must for all of that. So the existing ones and also with the new networks, the new extensions you are doing. Okay. There is another question, I think.
Yeah. So another question from Pak Norman from Perumda Tirta Pakuan. So does this application or the software can indicate the blockage rather than water loss?
Yes. Indicate
the blockage from distribution pipe blockage.
You want to ask about the blockage?
Can this software indicate the blockage in our pipelines?
So blockage in respects of like water quality analysis, something like that's asking, like any of that trace or something like that. Or you are asking that for that any, yeah, that can be done. That can be done. Yeah. So you can go with the pipe age analysis also, okay, but you need to give the informations, okay. How can background leakage and pipe burst leakage be modeled and calibrated in water so that the simulated water loss percentage matches the field minimum night flow? Be modeled and calibrated in water. So you need that field data, okay. So and you can go with the multiple iterations on that with the pipe roughness coefficients and changing demands and uh, also sorry, there's a metering coefficients. You can also just changes, and through that you can matches that loss percentage, so that minimum field, minimum night flow data. So in that minimum night flow data actually helps you to for that leakage. So that can be also done, and that I have mentioned about 4 a.m. So that by that way you can do it.
I think there's a question.
Yeah, Akshay has already shared one of that articles there. So if anyone interested in the much more about that, you can just have a look at it.
Pak Taufik, there's a question by Pak Muhammad Ghifari.
Yes. Okay.
Yeah. Thank you.
So Pak Muhammad Ghifari asked about the is the debit entering the system manual input, or is it automatically calculated from the end?
Both way could be done. Both way could be done.
So can we put something different from the total demand?
Yes. That can be done.
So the next question from Pak Wawan. How can background leakage and pipe burst leakage be modeled
I have just
and calibrated?
I gave that answer. Yeah.
Yes. So maybe this is from me to the new user from the open source water. Is there any space or is there any space to for we to learn about this open source water? Like can we learn about the sample models, like in other software we can use the quick lesson or something like that, so we can learn
The software, it already
to
has
this
the
software.
quick lessons. Okay, so we have the YouTube channels also, and the quick lessons is in the software already itself. So just if you go to the softwares, so it will directly show you some hands-on trainings. Okay, so it has step-by-step guidance, and even you can also have the trainings too. So if you just go to the files, here already we have the all that required links. Okay, so you can go with the let's start lesson. So you can get the models and everything. So this has some step-by-step guidance for everything. Okay. So it is very easy. So if anyone is or anyone of you are working in water supply network engineering and or not, so it has step-by-step guidance. And anyone who are working in in HIPAA nets, okay, so you know the basic, okay, so it will be much more faster to learn. But obviously it has much more advanced tools. So those you need to just learn with this. Okay.
Baik, Bapak Ibu, apakah ada pertanyaan lagi? Sampai jam berapa, Bu Nesi, ini kita?
Ya, sepertinya sudah cukup, Pak Taufik, untuk sesi tanya jawab. Terima kasih,
Baik,
Pak
saya
Taufik.
kembalikan ke Bu Nesi.
Ya. Terima kasih, Pak Taufik.
Thank
Thank you
you.
very much. Dipjoti, for your detailed and insightful presentation. We truly appreciate the knowledge you have shared with us today. Thank you. Hadirin yang kami hormati, mengingat keterbatasan waktu, untuk apabila ada pertanyaan lebih lanjut terkait open flows water, kita dapat berkomunikasi di WhatsApp grup water. Dan setelah acara ini, bagi yang menginginkan eval license, eval itu seperti trial license. Jika Bapak dan Ibu ingin mencoba softwarenya, kami akan memberikan selama 30 hari. Dan di dalam software tersebut juga banyak terdapat menu-menu fitur untuk self-learning. Oke. Hadirin yang kami hormati, terima kasih kami ucapkan atas partisipasi dan pertanyaan yang telah disampaikan. Semoga materi yang telah disampaikan dapat memberikan manfaat dan menambah wawasan kita semua. Atas nama Kurnia Handasa, saya mohon maaf apabila ada hal-hal yang kurang berkenan. Sampai jumpa di sesi kedua webinar dengan tema Digital Twin Selasa depan, 5 Mei 2026 jam 10 pagi. Sampai jumpa. Terima kasih semuanya. Thank you everyone. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you. Terima kasih.
Thank you. Terima
kasih.
kasih.
Thank you.
Thank you.
Thank you.
Thank you.